You're good. Sorry.
Okay. So there's a problem here, and a lot of people make this mistake. They write all their vectors as column vectors. The kernel of T, but remember the kernel of T is a subspace of V. So it should look like 2 by 2 matrices. So I don't want to write it this way. The way I want to write it so that it looks like an answer that makes sense is -1/2, -1/2, 0, 1, comma, 3, 0, 1, 0. Okay? And it's not like I'm going to totally destroy you on points if you wrote it like this, but I'm not going to be able to give you quite full credit either, so it's better to get all the points. Make sure that you're writing your objects as vectors from the space they belong to. So if you're talking about the kernel of this transformation, I need to be talking about 2 by 2 matrices. Okay? You see the difference?
So if we write it like this, what do you
We write
mean? If you write it like just in pairs with this, or?
well, this is the range over here.
No, I mean if we write this the same way as writing this in points, so we write -1/2, comma, -1/2.
Oh, yeah. You can't do this either. You want to do this?
Yeah.
No. That's not a 2 by 2 matrix either. It's got to be a 2 by 2 matrix. Okay? Make some sense? Awesome. Okay. Figure out what else I want to go into. And I understand if any of you are needing to leave or whatever at any point you can. I'm going to stick around though until I feel good about everything I've done. Covered quite a bit. Let's say a few things about inner product spaces. I'm going to give you the Graham-Schmidt formulas, so that saves your life a lot right there. You don't have to memorize anything too complicated. But let's talk about inner products. Okay, so here's a good example. I'm going to do the problem on the very last problem, which is number 12 on the review sheet. So I'm going to give you the vector space. We haven't talked about this one very much today. Continuous functions on the closed interval 0, 1. Just take calculus functions. Okay? And I'm going to give you this formula for what's going to be an inner product between the functions f and g. We're going to do it with integration from 0 to 1. Now the one that is standard that we most often use is just f of t times g of t times dt. But I'm going to change it a little bit for this example and change this to a t times f of t times g of t. So I am giving you this formula, right? We have to live with whatever formula I give you. There could be lots of examples. So sometimes I like to give people something that's a new thing to see if you can apply your old knowledge to something that's new. So here's what I want us to do here. I want us to verify the axioms of an inner product. For this example. This is part A, number 12. Okay? So I guess the first thing I want to do is see if anybody knows what the axioms are. I think it was on a quiz. Do you remember the, how many parts are there?
4.
4. Do you remember the 4 parts? Okay, what's the part? Yensing, do you remember one of the parts? No. Alcira, do you remember any of the parts? It's okay, don't worry about it. Let's see. What do you think? You know Ozzy?
What's up?
I'm looking for axioms of an inner product space, and I know, guys, if your answer is I don't know, don't worry about it. It's been like weeks since we did this, and I know that you haven't had a lot of time to start studying yet for your final. Just make sure you know them by next week, right? We need to know these, okay? So, I think you know one, Buddy. Why don't you go ahead?
I think A comma B is B comma A.
Okay, the inner product of A and B is the same as the inner product of B and A. So that's one, that you can switch the order of the vectors. By the way, guys, I'm grading your midterms from last night. There are still a lot of people who are not putting arrows on their vectors. They're just leaving them like A comma B without arrows on top. That really bugs me after a while. So I keep circling it on the papers. If something is a vector, you have to put arrow on top of that, otherwise it's confusing. Okay? Yeah, there's a scalar one. Do you know what it is?
Only one of them has a K.
Right, so there's a K in the first slot, but not the second, so we could have a vector K, so a scalar K times vector A times B.
No, that's equal to K and then the inner product of
Right, okay, so, guys, this does not work the same way, or does not look the same way as a scalar multiplication does. Because this K right here, if it was a scalar multiplication and you were thinking of these as components of a vector, you would distribute the K, right? That's not what happens in the inner product formula. There's only one K here. So, you know, the way you can tell is those angle brackets. I only use them for inner products, nothing else. Okay. By the way, even though we have vectors inside of these notations, the actual expressions that we were talking about here are numbers, if you remember. Right? Everything in here is a number. Okay, does anybody remember any other axioms now that we've started to write some of them down? Go ahead, John.
Vector 1 plus vector 2, inner product with y is equal to vector 1 times the inner product of vector 1, vector y, plus vector 2 with vector 5.
It's a mouthful, but you got it. Basically, inner products respect addition in the first component, and therefore also in the second component because you can switch them. So both components respect addition. So for example, you can do things like FOIL an expression out, right? So that's perfectly valid. And then there's one more axiom.
A inner product with itself is greater than or equal to 0.
Exactly. When you inner product, in fact, this is the one that is very important to know because it's often the one that might fail, right? So when you inner product a vector with itself, it's always at least 0, right? And there's a little extra bit here, which is that it equals 0 only if the vector was 0 itself to begin with. And notice I'm being very careful what has an arrow and what does not have an arrow on top of it. Okay? So there's these 4 parts. So now it says, verify the axioms of an inner product, which means these 4 axioms, for that function. Okay? Actually, let's not do all 4 parts because it's going to take all night. Let's just pick maybe 1 or 2 parts. Are there any particular parts that you guys would like to try to do?
First one.
You want to do this one? Okay, and Fadi wants to do this one. So let's do those 2. We're going to do the first one and the last one just to practice. We won't do everything. Okay, so let's do the first one. Now, in my notation for this problem, we're using F and G, right? So FG, right? I might give you a choice. I might say write down 2 of the axioms of an inner product and verify those 2. Okay? That'd be a reasonable question. All right, so this is the integral from 0 to 1 of t, f of t, g of t, dt. Agreed? Everybody good with that? And what should I do with this expression at this point?
Switch F and G.
We know we're trying to switch our 2 vectors, right? If I'm trying to switch my 2 vectors, then I want to do that right now and pull the G in front and then put the F, right? And then this becomes,
G.
yeah, this is the inner product of G with F. This is an easy one, right? Daniel's got a good nose for the easy one. Absolutely right. Okay, so that looks good. Everybody good with that? Now let's do the one in the bottom right corner. So for the bottom right corner, I've got to take the inner product of f with itself, right? Something like that. Oh, just plug into the formula again, right? This is just the integral from 0 to 1 of t times f of t squared, because you're applying the same function twice. Okay? What do I want to be able to say about that?
It's greater than 0.
Greater than or equal to 0 is what the axiom says right here. Is this greater than or equal to 0?
Yes.
Hmm?
Mm-hmm.
Why is it greater than or equal to 0?
Because the function is squared, so negative is not an option.
Okay, so
Yeah.
ft squared is positive, or well, non-negative, right? Non-negative. And I'm multiplying it by t. T is
Always positive.
always positive on this interval, but that leads me to an idea for a good test question. Would this have worked?
No.
Oh,
Yes.
if my interval is -1 to 0, t is now negative, right, on that interval. And then you'd be multiplying it by a positive squared, you'd be integrating a negative function.
It'd be negative of a negative. If you, it's negative when you, after you solve it, it'd be 0
Oh,
times
I see. Yeah.
t. And so we're,
All right, so we're still good. It's a negative function, but I'm evaluating, okay. Not a good problem after all. I tried. Trying to think of things that don't work. Anyway, this one works, right? So this is at least 0 since t f of